Hey guys, I'm Hamza here from aboutengineering.com, and in this video we're going to discuss about bisection method. And whenever you will have the bisection method question, you will have a function like here we have this equation here for the f of x, and you will be given with an interval which will be used to find the root. So first thing you guys want to do is put these limits or these values in your function to find out that either your root lie in this interval or not. The first thing we did here is put 5 in the function. We get 4.5 as an answer, and when we put 10 in the function here, we just put it 10 and 5 in the places of x. So we get minus 20.5 for 10. So you see the sign is changing. It means the root lie within that interval. So now next step is we need to just first let us just give our interval. We have our interval is 5, 10. Let's just name our interval to help ourselves to do the later calculations. Here for the positive value we get for 5, we will name it as our upper limit, and for 10 we get the negative value, we will name it as our lower limit, so that our calculation get a little easier. This will just make sense in a minute. Now we'll just create a table for our calculations. The first one would be for n, the second one would be for our lower limit, and then our upper limit, then for our root, and then for our f of r. R is for root. And for first calculation we will put 0 here, and as we named earlier the root which gives us a negative answer, we'll put it here 10, and the root which give us the positive answer, we should put it here. For the first iteration we will use r as a midpoint for our given interval. So r would be like r is equal to 10 plus 5 divided by 2, which is 7.5. So our first r is 7.5. So now put r is equal to 7.5 into your given function. So put 7.5 as we put 5 and 10. Then what we get as an answer is 5. 7.5, if we put it, we get answer as minus 4.875. You see guys, this is negative. So what we will do now is, as 7.5 gives us a negative answer when we put it into the function, it means the root is still on the right side. So we will replace 7.5 with 10, because that one was the root which gave us the negative answer in the first place. So if it would have given us a positive answer, we would change it with the 5. So it gives us the negative answer in this iteration too, so we will change it with 10. So now first we will change 10 and 5, and our new r would be 7.5 plus 5 divided by 2, and the answer is 6.25. So our new r is 6.25. So now we will put 6.25 into the given function, and what we get for it, let's just see. For 6.25 we get 0.59. So guys, you see we get a positive value for this. So this gives us a positive value, so we will replace 6.25 with 5. So let me just extend our table. Alright, the lines are not so great here. So for second iteration we will replace it 5 with 6.25. You see guys, our interval is shrinking, which is giving us an accurate r, which is our root. Now we will just calculate our new R, which is 7.5 plus 6.25 divided by 2. So our new R is 6.875. 6.875. So what is 6.875? Remember guys, we'll just put 6.875 in place of x in our given function f of x. So we get f of 6.25 as minus 1.95. So we get a negative value, so we will replace it with our lower limit. Whenever we get a positive value, we will replace it with an upper limit. So this makes sense. Negative value, replace it with lower limit, and positive value, replace it with the upper limit. So next iteration would be, get negative value, we will replace it with 6.875. Guys, I put the wrong value here, 6.875, and still it would give this answer. I have written down these answers, so for the time's sake. Now we have here 6.25. So what would be our new R? Our R would be like 6.875 plus 6.25 divided by 2, which will give us 6.56. So guys, here R is our answer, 6.56. We are really getting towards it. We are approaching towards the answer as we will keep the iteration going. As you guys can notice, the first one here we have a really huge difference between these two R's, and then the difference increased significantly, and now you see difference is decreasing along the way. So 6.56. Now what would we get in our next iteration? I'll just make it fast because time is passing by. Now for our fourth iteration, we will see what f of 6.56 gives us. F of 6.5x 56, when we put it in the function, gives us minus 0.617, which is a negative value. So we will replace it with our lower value, which is 6.56, now 6.25. Now what would be our new R? Our new R is, add them up and divide it by 2, we will get 6.405. 6.405. Now you guys see there is just 1 point difference in that. Now we will stop our calculations here because the answer is now approximately is equal to error is equal to 0.01. We will just get into the error. So our answer for the for this bisection method is, our root is 6.405. So if we put that value into the given function, we will get an approximately is equal to 0 answer. Now guys, let me quickly show you how we get our approximate error. Our approximate error is equal to our previous value minus our new value divided by our previous value. So 6.56 was our previous root minus 6.405 was our new root, and divided by 6.56. Right? Now and we need to place an approximate sign here, and then we will multiply with 100, which will give us the answer. We will get the answer as 2.36%, which is fairly good enough, and I will give you the answer approaching really close to 0. So that was it, the bisection method. And if this video helped you guys, then please like and share, whatever, and thanks for watching.